In a recent review from Stahl and al., they did a study, a review about the attribution of the disturbance agents, and they basically found that most of the approaches were based on a two-step analysis, where first the disturbances were detected mainly with with Landsat images, and then the disturbance agent was attributed in an automatic way using batch metrics, basically. And most of the studies were involved different thematic levels, thematic resolution, which was like between level 1 and level 2. These are the levels of the thematic resolution. It works. Yeah. So at the first level, which is the less specific, the disturbance agents are simply separated, divided as biotic, anthropogenic, and abiotic. But then at level 2, for instance, for abiotic disturbances, we have drought, wildfire, wind, and other kind of biotic disturbances. Then also for the biotic ones, there are deflators, bark beetles, and other disturbances like diseases. And most of the studies that were published right now consider either level 1 or level 2 of the thematic resolution. And our research questions, the general question was how the forest disturbance regime changed in the European Alps over the last 4 decades. And we also wanted to test if we can automate the attribution of the major disturbance agents in the European Alps. And we also wanted to test if we can accurately separate between natural disturbances and post-disturbance management. So this was the study area as defined by the Interreg Alpine Space projects, and is including Italy, Austria, Slovenia, France, Switzerland, Germany, and Liechtenstein. And it is scored by 45 Landsat scenes. We performed the detection of the disturbances using early Landsat mosaics produced within Google Earth Engine with medoid composites. And we used this algorithm that we developed called iLanding, which is based on the detection of linear trends, so changes that occur in the slope and in the intercept of the linear trends, and is able to analyze multiple spectral bands and indices, as well as pixel within spatial kernels. As you can see on the rightmost panels, this algorithm is able to detect primary disturbances like natural ones, like fire or bark beetle or wind throws, and then the following disturbance associated with post-disturbance management like salvage logging. So we considered 7 major disturbance agents, and which were the most common within the study area. And we collected more than 2,000 training samples as established forest patches. For this job, we used mainly field data provided by the project partners. So we had data like in polygons or in point formats that were telling us the disturbance agent. And for some of them, we also had the data when the disturbance occurred. We also used this European dataset, the IFE SAS, which was published by the JRC in 2023. And we also used some remote sensing data such as high spatial resolution, aerial and satellite imagery, and Landsat imagery too. For the modeling approach, we selected several Landsat-based spectral metrics, disturbance metrics, some bioclimatic variables, as well as topographic variables and patch metrics. And we analyzed this data, these predictors, using a boosted regression tree model in the MLR3 framework, which allows us to separate between the training data and the test data. In particularly, we used a buffer, such as an exclusion zone, for separating the test dataset with the training dataset to limit the effects of spatial autocorrelation between data. These are the results relative to the disturbance maps. Kind of examples, some examples you can see of the major disturbance events that occur within the study area throughout the time series, so between 1985 and 2022. Some of the main storms, and for instance, the severe drought that occurred in France in 2023, or wildfires in the southeastern part of France, and the sleet, the ice damages caused in 2014 by ice in Slovenia, and other big events. These are the maps relative to the spectral change magnitude that is a good proxy for the disturbance severity. Then here you see some examples of early disturbances that, in particular, beetle outbreaks that occurred after major disturbance events, like the Vaya storm in 2018. And you see these orange patches followed by other patches that are caused by the beetle attacks. And similarly, you see these kind of patches associated with beetle attacks following the ice damages in 2014 in Slovenia. Regarding the accuracy of these maps, we obtained quite good overall accuracy, around 85%, but for some of the agents, like fire, insects, and also mass movements, they were not as high. They can be improved. We are still improving this model, this classification model, but we were quite satisfied for the main, all the other disturbances, as we obtained accuracies that were higher than 80%. And for regarding the feature importance, so the most important variables within the model, we found that spectral metrics and the disturbance metrics were the most important ones. In particular, looking at the dependence plots, we saw that the spectral change magnitude, in particular the range of the values of the normalized different points to index within each disturbance patch, was a very good predictor for discriminating between patches disturbed by insects and all the other disturbances. As you can see, there is a quite strong variability in the probability of for a patch of being disturbed by insects. If we look at the effects of this predictor, and then similarly, we saw that the total disturbed area in the same year, computed within a spatial buffer of 10 kilometers, was a good predictor for separating between patches disturbed by wind and all the other disturbance agents. Then we also found that the elevation range within disturbed patches was a good predictor for classifying patches disturbed by human activity. Then we also see that for those patches disturbed by mass movements, so in the alpine space, they are mainly related to snow avalanches. The number of snow cover is a very good predictor for separating between these kind of disturbances and all the others. So, as a conclusion and the perspectives, we can see that we can say The availability of field data is a major limit for increasing the thematic resolution of the disturbance maps. And me and my colleagues are going to include more feature variables like length over data for improving the classification accuracy of those agents that were not correctly or not that much accurately detected. And then also the annual frequency of these Landsat time series that were analyzed are limiting the detection of those intra-annual events. And in general, the changes in disturbance regime is fundamental information for guiding post-disturbance management. So, thank you for your attention.